Hello everyone, in this video we are going to discuss Chapter 8 in Stairway for Scientists and Engineers under the title of Conservation of Energy. This video is represented by Rawan Hisham Mustafa, a student at STEM Ismaila High School. Please support this video. I'm at the class of 12.5. So let's go to the next slide. Here's the next slide. I'm showing you the concepts we have in this chapter. We have 5 concepts. The first concept is analysis model. And the second concept is analysis model 2. We're going to discuss non-isolated system and isolated system. About the third concept, we're going to involve situations, kinetic friction, and the fourth one, changes in mechanical energy for non-conservative forces. And we are going to know what is the difference between conservative and non-conservative forces also. The fifth thing we are going to discuss is power. So let's get started. So guys, here in the slide I'm talking about the analysis model for non-isolated system. So what is meaning by the non-isolated system? Non-isolated system is one for which energy crosses the boundary of the system. Like I'm a system, I can take energy from outside and relieve energy. So I'm non-isolated system, like I'm not isolated. I can interact with the environment. So let's see the definition here. Non-isolated system, therefore, to establish law of conservation of energy. Non-isolated system, I can interact with the environment, means I can lose energy, I can take energy. Then how conservation of energy can be established? Conservation of energy can be established by this equation. Like a change in the energy of the system is equal to the total transfer of energy out of the system or into the system. Like if the body is 100 joule and then it became 50 joule, there is a loss of 50 joules. This loss of 50 joules is equal to the transfer of energy that happened outside of the system. So here, LE system is the total energy of the system, including all methods of energy storage. We have 3 types of energy storage. Number 1, kinetic energy. Number 2, potential energy, and internal energy. And for T is the amount of energy transferred across the system boundary by some mechanism. As I said, T is the transfer of energy out of the system, and the transfer of energy, we have many forms. Transfer can be transfer of work, can be transfer of heat, and we for appreciation, for abbreviation, we can call it letter Q. And then for the transfer of mechanical waves and transfer of electromagnetic radiation and etc. There is a lot of energy that can be transferred out of the system and into the system. So in general, non-isolated system can interact with the environment, lose energy or gain energy. And therefore, to establish conservation of energy, I have to make the change in the energy of the system is equal to the total transfer of energy, whether out of the system or into the system. I hope it makes it clear. So let's go to the next slide. So here in the next slide, I'm talking about the non-isolated system also. So since I talked about a change in the energy of the system is equal to the total transfer of the energy, so the energy of the system, as I said, I have 3 cases: the kinetic energy and the potential energy and the internal energy. Those are the energy that the system can have. And transfer of energy, we discussed the many formulas like work in Q and T, matter transfer and electromagnetic radiations, and every transfer of energy that can happen. So we can make it that general equation that works for any non-isolated system, whether any type of radiation that can happen, transfer of energy out of the system or into the system. So any change of any non-isolated system can be represented by this equation, and also by putting 0 values for the transfer of energies that are not involved in the system or in the questions that I have. Okay, so this representation is talking about if I have a system have kinetic energy, potential energy, and internal energy, and a transfer of energy happened, whether work in or out, heat in or out, mechanical waves in or out. All of this makes a change in the kinetic energy or in the total energy of the system. Therefore, this equation works very well. So as you can see, the change in the total amount of energy in the system is equal to the total amount of the energy that crosses the boundary of the system. Amount of energy that crosses the boundary of the system causes a change in the energy of the system. I hope that makes it clear, and that's how we achieve conservation of energy. As we know, the law of conservation of energy says that energy can neither be created nor destroyed, but it changes from one form into another, and that's what exactly happened. What about the next slide? Okay, here in the next slide, I'm talking about the isolated system. And typically, isolated system is the inverse of the non-isolated system, as isolated system does not interact with the environment. Isolated system is one from which no energy crosses the boundary of the system, therefore change in the total energy of the system equals zero, as no energy transferred to the isolated system as time passes. So I have no interaction with the environment, so my total energy will stay constant as time passes, therefore there is no change, and therefore change in the system, change in the energy of the system is equal to zero. I know that's simply clear. I hope you get with me. So let's go to the next slide. Okay, here in the next slide, I'm talk about the two different concepts that we're gonna help us with the following concepts of this chapter, which are conservative forces and non-conservative forces. So what is the meaning of conservative forces and non-conservative forces? As we know, there are many forces in our life, like gravitational force, friction force, and many type of forces. So scientists decided to make a difference between um, those type of forces, like make a difference saying this conservative force and this is non-conservative force according to some situations. So now we're going to know what situations they called the forces of force of gravity, spring force, electromagnetic force, magnetic force, a conservative force. So conservative force is the one where the work done an object by the force is the same regardless of the path taken by the object. So we are going to see an illustration later by pictures, but now let me talk about you. Conservative forces does not depend on the path taken. Whether I'm going horizontally, I'm going on an inclined plane, the gravity want to change, the force of gravity want to change, and the spring force want to change, electromagnetic force want to change. All of this are not dependent on the path. They are independent of the path taken, okay? So, to say that I have conservative forces, two cases must be done. The first case is conservative force on an object moving between 2 points is independent of the path taken by the object. Second is work done by a conservative force on an object moving through any closed path equal to zero. So, conservative force, if I said I have a book, and the book I left it up from the ground, so up and then to the left and then down and then to the right. I return it to the same point and started at, so this is called a closed path. So a closed path, like imagine the gravity is the conservative force on the book. So and I moved a closed path. Therefore, the work done by this conservative force is equal to zero because the values will going out to be some positive and negative and zero. So they cancel each other to be a zero quantity. So a closed path is the path where the initial and final points are the same location. So let's go to the next slide. Okay, here I said that I want to make it clear. So here we have pass 1 and pass 2. So pass 1 is an inclined plane and the pass 2 is, as you see, it's curved. So here, as you can see, the work of the gravitational force didn't change. It is 1000 joule as it is because it is conservative force that doesn't depend on the path. As you can see here in the note, although the path taken by the moving object is different, the same work of gravitational force has the same value, which is 1000 joule, as the same distance covered, which is 100 meter. Of course, I'm saying same distance because work is force times distance, so I'm sure that is a conservative force won't change by the path, but the work is dependent also on the distance, so I have to make sure that the path 1 and path 2 cover the same height, which is 100 meter. I hope it makes it clear for you, and let's go to the next slide. So here in this slide, It's talking about non-conservative forces. So, non-conservative force is the opposite of conservative force. Non-conservative force depend on the path taken, like friction. If I said that, as you can see here, I have two passes. Pass 1 is an inclined, pass 2 is a curved. If I place an object on the inclined plane and the body moves, then I have a friction force. Different if the body is placed in the other pass and the friction force happens. As you can see, the curved one has more friction force because it has a longer distance, therefore a friction force is more. And therefore, as you can see, for the pass one, that work of friction force is equal to negative 300 joule. Negative because it slows down the object, and the pass 2 have a work of friction force equal negative 500 joule because it slows down the object also. So as you can see here, let's read the note. The force of friction is a non-conservative force. A non-conservative force is the one where work done an object by the force depend on the path taken by the object. And as you can see here, it depends on the path taken as the value changed. Let's go to the next slide. So here is the summary. I listed all the conservative forces and non-conservative forces to illustrate for you what are these types and what are these types, and to imagine how gravity don't depend on the path taken, how friction depend on the path taken, how applied force really depend on the path taken, push, tension, all of this depend on the path taken, while conservative forces does not. Gravity, elastic, electrical force between two positive and negative electron have electrical forces. They don't depend on the path taken. They are constant quantities. Gravity also is a constant quantity. Elastic is a constant quantity. Does not depend on the path taken. Therefore, it's called conservative force. Let's go to the next slide. So here we have all the rules. So since I said there is a conservative forces and non-conservative forces, then you can imagine that the work net is equal to conservative work plus conservative work plus non-conservative work. Like if the word is consists of work conservative and work non-conservative, then if I wanted to get from a system the net work, then I have to add them both. So now it's known. Please look at the side where it is here. It says mechanical energy is equal to kinetic energy plus potential energy. We know this one. And also we know that the net work from um, from class 9 and grade 9, we know all of the things, that the work net is equal to change of mechanical, of electrical, sorry, of kinetic energy, and work conservative is equal to negative change in potential energy. So in this equation, if I want to get the work non-conservative, I would say, okay, I just want to get this, so let me get this by the negative sign, and the work net, I said it's change in kinetic energy, so I'm going to put it here, and the work conservative here is negative change in potential energy, so it's when in gun it's by negative, so negative negative be positive, and here delta kinetic energy plus delta potential energy is magnetic is mechanical energy. So work non-conservative is equal to change in mechanical energy, as you can see here in the conclusion. I hope it makes it clear for you. Please, if you have any confusion, stop the video and think about that. So as you can see, all the rules are rested here: mechanical energy, work conservative, work net, all of these things. I hope it makes clear for you. The next slide. So guys, let's go to this slide. This slide, let me get the pencil and write with you and interact with you. So as I said in the next slide, the work non-conservative is equal to the change in mechanical energy. Therefore, if the work non-conservative is equal to 0, therefore the change in mechanical energy is going to be equal to 0 too. So what is meant by work non-conservative is equal to 0? This means this is work conservative is the only work exists in the work net, as we said before. Work conservative is the only work that exists. So, therefore, if a conservative force acts on an isolated system, and as we said before, isolated system is the total or the change of the energy of the system is always equal to 0, as it is isolated, no interaction with the environment. Therefore, the change of the energy of the system is equal to 0. So if a conservative force acts on an isolated object only, means no conservative force, yeah, therefore change in mechanical energy is equal to 0. So instead I said for an isolated object, change in energy of the system is equal to 0. No, but I said change in mechanical energy, so I specified mechanical energy. And as we know, since mechanical energy is a change in kinetic energy plus a change in potential energy, excuse me, therefore the change in kinetic energy plus the change in potential energy is equal to 0 too. As you can see here, change in energy of mechanical energy is equal to 0, and mechanical energy is equal to kinetic energy plus the potential energy. Therefore, since this is equal to 0, then this also is equal to 0. As you can see here, they are equal to 0 too. Therefore, next go to the next slide. I hope the slide was clear for you. Please, if you have any problems, stop the video and think about the informations slowly. Okay, let's go to the next slide. Whoa, see guys how we get into the concept number 3 in this video. So now we are going to talk about situations involving kinetic friction. So here Survey Book have some laws I would like to share with you. They are so much simple and fast, so I just listed all the laws in this section to be easy for you. Then let's take a pencil and talk about you what is going on in this slide. So here, Survey Book in this section wanted to calculate kinetic friction. So in order to calculate the work of the kinetic friction, he made many steps. Then he stated this law. So this law says that the sum of the work of other forces, like other than friction force, and all the work forces act on the system. Like if I have a body, okay, and many forces, like force like this one, force like this one, anything, but just he neglected the friction force that's going in this side. Let me do it with another color. So the friction force is the object moving this side and this side. So if this is bigger one, if this is a bigger one, so if this a bigger one and pushing right there, so the friction is gonna be right there. So he concluded all the friction force. Okay, sorry, the message is not really clear, but I tried my best because I'm on the laptop. So yeah, this is friction force, and this is force. This is force, and this is bigger than this force. Okay, and this is friction force. Okay, I can just do it to double F. Anyways, friction force is opposite to the motion of the force. So, to calculate the work of the kinetic friction, he said that the sum of the work of other forces act on the system minus the friction force times the distance means that the work of the friction force times distance is equal to the work, as we know before. Work. So this is the work of the friction force because he multiplied the force of friction times the distance, which is the work of friction force. So he minus all the work of the other forces minus the work of the friction force. It gives me the change in kinetic energy. So it gives me the change in kinetic energy, and as you remember, we before said that the net work is equal to change in kinetic energy, as we said before, change in kinetic energy, as we said before. So he said also that the work of other forces minus the work of friction is equal to this. So make sure you get this note and write down in your book. The next one is a change of energy of the system. So he said that for an isolated, this one for isolated system. So he said the change of energy of the system is equal to, he considered a book, okay, sliding on an inclined plane. So the change in kinetic energy plus the change in energy, internal energy of this body sliding. So the change in kinetic energy and the change in internal energy is the change of the energy of the system is equal to zero, as it's isolated. As we said, the isolated does not interact with the environment, therefore its energy stays as the same, therefore there is no change. Okay, there is no change, the kinetic is the same, everything is the same. So he just said that, and therefore, if we say that it's an isolated, therefore it'll work other forces and that it's not exist. If it's not exist because the system is an isolated in this case that we're talking about, therefore change in kinetic equal friction force times the distance, which is the work of friction force. So um so it's coming up to be like so. And here what is going on, and here what is going on. So as we said right there, we cancelled the work of other forces, therefore the change in kinetic energy is equal to the friction force times the distance. So we can remove this one, and put this one with a positive value, which is the force of the friction times the distance. So the change in, so it's right there, as you can see, this the negative sign because we just put it 0 minus equal kaza. So we gonna put it right there, and plus kaza is equal to 0. So here change in internal energy is equal to friction force times the distance. So here is the equation, and here, as we said, the change in the work of other forces is equal to the work and change of the kinetic energy, and since the change of the internal energy of the object is equal to the work of the friction force, therefore to address the friction force, the kinetic friction, I don't have to put another thing. It's also the same as the energy internal, it's converted to the energy internal, therefore the work of the system is equal to the work of the other forces, not change in this one. And let's go now to the next concept. I hope this slide make it clear for you for the kinetic friction, and I just put all the laws to make it more simple for you and to memorize them. I hope you understand all of them. If you have any problems, stop the video and think about it clear. So guys, let's go to the next concept, which is changes in mechanical energy for non-conservative forces. So as we said before, that the change in energy mechanical is equal to change in kinetic plus a change in potential energy gravitational is equal to negative work of friction force is equal to negative change in energy initial. So we said before that this part is equal to this part, so it's okay with that. And about this part, so this part is change in energy mechanical. We said before the energy mechanical is equal to change in kinetic energy and the change in potential energy. We said this one before, but why is it equal to negative the work of the friction? So as we said before, um, if I have a book and the book is going through this horizontal space, so just imagine it is a horizontal one, and the friction is going to be opposite to the side, so the work is going to be opposite, the energy is opposite, and therefore it's going to be negative. So in general, let me just realize this one. So in general, if a non-conservative forces acts within an isolated system, so what mean isolated system? The system total energy is equal to 0, and the total energy is equal to change in kinetic energy, change in potential, and the change in internal energy. I hope this one is clear, and this one is clear also. This one is negative, as we said, because it is opposite to the direction. This is opposite to the direction. So the change in mechanical energy, the book is going to this way, and the friction is going to this way, so it's going to be negative, it's opposite to the sign. Okay, like I mean this one This one for a non-isolated one. Why it's an isolated one? Because the change in kinetic energy and the change in potential energy are went to the work of friction. Like the work of friction took from the total energy of the system to go to the friction. So the friction talk, so that's why it is negative. It is the opposite direction, okay? And then now we're going to talk about this one. For non-conservative forces, instead of putting delta kinetic energy, we put delta mechanical energy. As we said before, the work non-conservative is equal to the change in mechanical energy. Therefore, we put it right there as we consider the potential and the kinetic energy also. As you can see here with the kinetic, and we consider the potential energy and the internal energy to say the work, and the work is equal to the work of other forces. We here consider all of the non-conservative and the friction, also friction force, since the energy internal is equal to the friction force also. I hope this slide is clear and this concept is clear for you, and let's go to the next slide. And now guys, we went to my favorite part and the last part, which is power. Power, power gives me the power to talk right now. Well, power, I love derivative to be honest, but I don't love integration. But derivative for me is very good. So as we talked before, power as we talked in the classes before. So let me talk with you. Power is equal to energy over time, as we talked before. It's also equal to work over time, since work is a type of energy. Like if I added energy, I added work. There is no difference at all. So this is power equal energy over time and the work over time. They are the same. So if I wanted to get the instantaneous power, instantaneous, as you know, the derivative, it's get like if I have a piece of object like this, and if I want to divide it into slices, so the derivative, I'm approaching to the nearest smallest slice, which is this one, for example. So instantaneous, I'm getting the power at the instantaneous energy, like the energy which is really small, you know, like the derivative energy is, I'm approaching to zero, like it is the limit approaches to zero, okay? So I'm approaching to the minimum energy, like instantaneous energy at the instantaneous time to get the instantaneous power, you know. So the next one, I'm going to get the average power. So average power, I don't want a derivative. Instead, if I'm going to use derivative, I'm going to use integration with that, because I'm gonna integrate the sports to get all the sports, you know what I mean? But instead, I can use the work of the work, the power average is all the work I did, divided the change in time. So note the difference between the change in time and the d time. So the d time, I'm approaching to zero. The change in time may be 5 seconds, maybe more than zero, not that much so. So the next one, if I want an instantaneous power but using the term of work over change of time, what I'm gonna do, I'm gonna do the limit as I said above. Limit here, the time approaches to zero. So as time is approaches to zero, I'm getting the power, okay, when the work at the time approaches to zero. So I'm going to, it's the same as delta W over delta T, the same as this one, but I'm converting just energy in the work. Just I'm saying that the energy is the same as work, you know. We can say it's limit instead of derivative and all of these things, okay? So the next one I'm going to talk about is the power is a change in is the change in work over change in time. And we know work is equal to force times the distance. So I'm going to take here force times the derivative of distance, because the distance changes at the, since it's a change in work, therefore it's a force is constant. I'm doing the same work, but the distance is changing, therefore I put dr over dt, as we know. And since the dr over dt is equal to v, therefore I'm going at to put f times or a dot, because it's a vector, dot v vector. Therefore, how many rules I have for power? I have power e over t. So like this one, if I'm gonna instantaneous, if I'm going to get it average, if I'm going to get instantaneous of other terms, if I wanted to get it in other terms, instantaneous or even average in general, f dot v. So Here, the last thing I'm going to talk about is the units for power. It can be horse, like this one horse is equal to 746 watt, and 1 watt is equal to 1 joule per second, 1 kilogram times meter square over second cube, 1 kilowatt per hour. I'm going to get 10 power 3. 10 power 3 is the watt, like 1 kilowatt is equal to 10 power 3 watt times an hour. I'm going to convert it into a second. So 1 hour is equal to 3,600 seconds. So it's going to give me 3.6 times 10 power 6 joule. I hope really guys, this illustration, we just talk half an hour. I hope that you got the chapter in half an hour. I did my best to illustrate for you. Please, if you like the video, don't forget to put a thumbs up and leave a comment if you have any question. My name is Iran Hisham. It was pleased to teach for you, and thank you for watching. Bye. Let me type it on the board. Bye. Bye, guys. See you.